The urinary system is our friend. No matter how many times it wakes you up in the middle of the night, remember, the urinary system is working for you. Its main job is to constantly remove waste from our bodies by forming urine. It also maintains normal blood composition. So just like a water purification plant filters bad stuff out of water, the urinary system filters waste from the fluids in our bodies and returns good stuff to our blood. The whole urinary system is made up of a pair of kidneys, a pair of ureters, a single urinary bladder, and a single urethra. We'll tackle the kidneys first.
Section A, the kidneys and urine.
The kidneys are two bean-shaped organs. They're located in the superior lumbar region, an area discussed in the Anatomically Correct World of Anatomy, Part 1.
There are three regions in the kidney: the outer renal cortex, the middle renal medulla, and the inner renal pelvis. The kidneys are responsible for removing nitrogenous waste. That's waste that contains nitrogen. The kidneys remove these wastes by forming urine. This maintains a healthy acid-base fluid balance in the blood.
The main structures that make up the kidneys are tiny blood processing units called nephrons. They are the functional units of the kidneys, the workhorses, you might say. These little nephrons carry out the processes that form urine. And who could ask for a more fulfilling job?
There are over 1 million nephrons in each kidney. Each nephron is made up of a renal corpuscle and a renal tubule.
The renal corpuscle is responsible for glomerular filtration. Glomerular filtration is the first process in urine formation. The renal corpuscle is made up of two structures, the glomerulus and another structure called the glomerular, or Bowman's capsule.
Now, while the glomerulus may sound like a race of different-looking, and therefore evil, creatures from Star Trek, it's not. The glomerulus is actually a small tuft of capillaries. The glomerulus is surrounded by a capsule which is attached to the renal tubule, a structure that we'll give you the details on in just a moment.
The glomerular, or Bowman's capsule, is the other part of the renal corpuscle. Basically, it's a large cup-like structure that completely surrounds and engulfs the glomerulus, kind of like how a broken-in baseball glove engulfs a baseball. And don't forget, Bowman's capsule and the glomerulus also form the renal corpuscle, and it's in this section where the filtration of blood takes place. To sum it up, inside the renal corpuscle, bad stuff go bye-bye.
Just remember that the renal corpuscle is in charge of the glomerular filtration. You don't have to know that much detail, because, hey, this is anatomy, not physiology. In any event, you do know about the glomerulus now. But still, that's only one of the structures that makes up a nephron. Another structure is the renal tubule.
The renal tubule's job is to selectively reabsorb water and substances like sodium, potassium, calcium, and other important stuff that's needed by the body. It also secretes waste no longer needed by the body.
The renal tubule is divided up into three regions.
These regions are the twisty-turny proximal convoluted tubule, the U-shaped loop of Henle, and the twisty-turny distal convoluted tubule.
The proximal convoluted tubule, or PCT, is the highly coiled region of the renal tubule that is continuous with the glomerular capsule.
Connected to the PCT is the loop of Henle. The loop of Henle is a hairpin loop that links both convoluted tubules, the PCT, and the distal convoluted tubule, or DCT for short. The portion extending from the PCT is called the descending limb of the loop of Henle. The portion connected to the distal convoluted tubule, or DCT, is the ascending limb of the loop of Henle. The distal convoluted tubule, or DCT, emerges from the loop of Henle and forms the final region of the renal tubule. In all of these tubules, water continues to be absorbed and waste continues to be deposited.
We're not going into detail on the formation of urine, so don't feel like you're missing anything. If you want to know more about urine, send a self-addressed stamped envelope to Fun with Urine, 2890 Emma Lee Street, Falls Church, Virginia, 22042. You'll be glad you did.
Well, that's the end of the renal tubule. Now, I know there's a lot of confusing loops, tubules, twists, and turns in the renal tubule, but that's because the extra length these curves create allows the renal tubule to process waste more effectively. More surface area means more filtration. So do yourself and the renal tubule a favor and rewind the tape if you're confused or need a review.
When the urine formed in the renal tubules exits the DCT, it's delivered to a collecting duct. The collecting duct collects urine. Wow, what a great hobby.
The collecting duct collects urine from the DCTs of a whole lot of nephrons. You see, the millions of nephrons in your kidneys all have DCTs that empty out into collecting ducts. These collecting ducts deliver the urine to the renal pelvis. Then it flows into a ureter. Remember, each kidney has a ureter, so you have 2 ureters. But unfortunately, before we move on to the ureters, we have to talk about severe kidney disorders.
Sometimes, when a lot of nephrons are damaged or can't function right, a condition known as renal failure occurs. When this happens, people have to undergo dialysis, where they are placed on a machine called a dialysis machine.
Hemodialysis is the most common form of dialysis. In this process, blood is rerouted through a machine that contains a semi-permeable membrane suspended in a bathing solution. The membrane removes wastes from the blood and traps them in a bathing solution. Important substances the body needs can re-enter the blood from the bathing solution. Sometimes, in cases even more severe than this, a kidney transplant is required.
It's true. Renal failure is frightening. But never forget, all those other times when your kidneys are working, that's renal success. And now, on to the ureters.
There's not really much one can say about the ureters. They're really thin. They conduct urine from the kidneys to the urinary bladder. Pretty simple, huh? Now, the kidneys are an important part of the urinary system, but the precious urine they create would have no place to go were it not for the worm-like ureters, the cavernous urinary bladder, and the muscular urethra.
Section B, the urinary bladder and the urethra.
The urinary bladder and the urethra are the last few rest stops for urine on that highway of relief.
The bladder is a collapsible muscular sac that lies just behind and below the pubic symphysis. The pubic symphysis is the cartilage that connects the 2 sides of the pelvis. The bladder's prime job is to temporarily store the urine that's constantly being produced by the kidneys.
The next adventure on the urine itinerary is the urethra. The urethra is a muscular tube that transports urine from the bladder to the outside world so that everyone can enjoy it. All people.
The urethra contains 2 muscular structures called sphincters. It has an internal urethral sphincter made up of smooth muscle. The internal urethral sphincter is under involuntary control, meaning you can't control it consciously. The other sphincter in the urethra is the external urethral sphincter. It's made up of skeletal muscle and under voluntary control. We'll go into more details on the sphincters in a sec. Just let us elaborate on the urethra for a bit longer.
At 8 inches, the male urethra is a lot longer than the 1.5-inch female urethra. The male urethra also conducts urine and semen, while the female urethra conducts only urine. Well, that's the bladder and the urethra. You should be thankful for these organs. They make micturition, the act of emptying the bladder, possible.
You see, when the bladder fills up with urine, its smooth muscle contracts, causing the internal sphincter to open wide.
So if you're not ready to go because you're in church, running a road race, or dancing with your prom date, your body helps buy you some time.
We can use our external sphincter to temporarily delay the release of urine. You know, hold it in. This is because the external sphincter is under voluntary control.
Unfortunately, this little trick can only work for so long, because the external sphincter will eventually give way to building pressure, and then Niagara Falls. But hey, we're lucky we even have the ability to hold it in, and sometimes we take it for granted. Urinary incontinence is the inability to voluntarily control urination.
Urinary incontinence is normal in infants because babies haven't developed control over their voluntary external sphincter.
Unfortunately, incontinence in adults is usually caused by emotional trauma, pressure from the uterus during pregnancy, and nervous system disorders like multiple sclerosis. So if you're healthy, be thankful for your healthy urethra, as well as your bladder, kidneys, and ureters. By Job, be thankful for your entire urinary system, even on those cold winter nights when nature calls.